Today, we'll be solving LeetCode 572, subtree of another tree. This is a classic binary tree problem where we're given two trees, one large tree called root, and one smaller tree called subroot. Our task is to determine if subroot exists as a subtree somewhere inside root. Let's break this down. A subtree means that we're not just looking for a node with the same value, we're also looking for the entire structure beneath that node to match exactly with subroot. That means both the shape of the tree and the values at every node must be identical. To solve this, we'll take a recursive approach. First, we'll check if the current node in the root tree matches the subroot. If it does, we'll verify whether the entire subtree starting at this node is exactly the same as subroot. To do this comparison, we'll write a helper function that checks whether two trees are identical. This function will compare the current node's values, and then recursively check both the left and right subtrees. If the current node doesn't match subroot, we'll move to the left and right children of root, and repeat the same process. We'll keep doing this until either we find a matching subtree, or we reach the end of the tree. Now let's go through the code step by step. First, we define our main function as subtree. If the current root is null, we return false immediately because there's nothing to compare. Next, we use a helper function called isSameTree to check if the tree rooted at the current node is identical to subroot. If it is, we return true. If not, we recursively call isSubtree on the left and right children of the current root, checking if either side contains the matching subtree. In the helper function isSameTree, we start by checking if both nodes are null. If they are, we return true, that means both subtrees have ended together. If one is null and the other is not, we return false, that means the structure is different. If both nodes exist but the values are different, we also return false. Finally, if both nodes exist and their values match, we recursively check their left and right children to ensure the entire structure matches. The time complexity is O of m times n, where m is the number of nodes in the main tree and n is the number of nodes in the subroot tree. In the worst case, we might compare subroot to every subtree in the main tree. The space complexity is O of h, where h is the height of the tree, because of the recursion stack. And that's how you solve LeetCode 572, subtree of another tree. Thank you for watching and let's keep learning.